James plots the points A57, B1 minus 1, C13 4, and D3 minus 2. He claims he can draw a line perpendicular to AB that passes through the midpoint of both AB and CD. Is he correct? Explain your answer. So to work this out, if I were to sort of give a rough idea of the points to understand the question better, that well, these are the axes, right, x and y. So the point A, roughly, without going by accuracy, if I do a roughly, where would it lie? A the point A, 5 and 7. So if I say put A here, 5 and 7, and B is 1 and minus 1, so 1 and minus 1 say somewhere here, so that would be the point B. So that's AB. And then the point C is 13 and 4. So the x coordinate is 13 and y 4. So, well, maybe put it somewhere here. So that's the point C, 13 and 4. And the point D is 3 minus 2. So somewhere here you'd have, say, 3, and then minus 2 is, say, somewhere here, approximately, So this is CD, 3 minus 2. So what James is saying is that if he joins the midpoint of these two lines, so let's say this is a midpoint and somewhere here is a midpoint, and if he joins them and draws a line, my line is not straight at all, but this is for like a demo purpose. It's not really something we have to do for the question. You can do it very well without drawing anything, So, but I just did it so it's easier to understand the question. So what are they asking us to do? So we have joined the midpoints, and let's say this is xy. So this is xy. Instead of saying xy, let me say something else like m and n. So if mn is he's claiming that he can draw a line perpendicular, so he's claiming that mn is perpendicular to AB and passes to the midpoints of both AB and CD. So what we have to do is, first of all, we have to find the midpoints. So these are the midpoints. So we have to find the midpoints of AB and CD. And then we have to find we have to find the equation of a line, of the line MN. And then we have to find the gradient of AB. And we need to show that the gradient of AB and the gradient of MN, using the two gradients, we need to show, or rather we need to see if they are perpendicular. If they are perpendicular, then James is right. If they are not perpendicular, he is wrong. So that's the plan of working out. So if I were to do this, we would first have to find the midpoints of AB's and CD. So the first thing is find the midpoints of AB and CD. Then number 2 is find the equation of MN supposedly perpendicular to AB. That is what is being claimed by James. He can draw a line perpendicular to AB, and then compare the gradients. Find gradient of AB, compare the gradient, sorry, my spellings are right. Compare the gradient, I meant to write gradient actually. compare the gradient of AB at Mn. So that's what we have to do in overall. So let's start this. Let's do the first thing to do is, therefore we need to find the midpoint. So to find the midpoint, we know we use the the formula. The midpoint is given by midpoint of AB x1 plus x2 divided by 2, so it would be 5 plus 1 out of 2 comma 7 minus 1 out of 2, and that would give us 6 out of 2 is 3, 7 minus 1 is 6, out of 2 is also 3, so 3 3, and then the midpoint of CD would be given by 13 plus 3 divided by 2 and 4 minus 2 divided by 2, and that would give us 13 plus 3 16 divided by 2 is 8, and 4 minus 2 is 2 divided by 2 1. So that's the midpoint of CD. Hope I got it right. Plus 3 16 out of 2 is 8. So then we need to find the equation of the line that passes through the midpoints. Equation of the line that passes through the midpoints. Oh, you know what I'm thinking? Do we really need to find the equation of the line, or would it be enough if we found the slope of that line? I think it would be enough if we found the slope or the gradient of that line, Mn, midpoints, that is Mn, because we got the two points already. And so if we can just find the gradient of Mn, probably we don't have to find the equation of the line. So I'm wrong here. We don't need the equation of the line. So it's we don't want to do too much work, but it's not needed. I'm already doing a bit more work probably. But so what, let's not find the equation of the line, right? So what we find is, we find the slope or the gradient of the line Mn. So I will say that we find the gradient of the line Mn. Okay, so the gradient of the line Mn, not the equation. Okay, so I've changed my strategy a little bit, but that's all right as long as we get the right answer. So we find the gradient of the line Mn. So the gradient of the line Mn would be y2 minus y1. So that if this one was x1, y1, and this is x2, y2, then the gradient would be y2 minus y1, so would be equal to 1 minus 3 divided by 8 minus 3, that would be minus 2 divided by 5, so minus 2 out of 5. And now the gradient of the line AB is gradient of the line AB. So gradient of the line AB would be, again, AB here. If we take, this is x1, y1, and this is x2, y2. So then it would be minus 1 minus 7 out of 1 minus 5. That would be minus 8 out of minus 4, that is 2. So the gradient of the line AB and the gradient of the line MN. So we see that one is 2 out of 5, minus 2 out of 5, and the other is minus 2. So the product of gradients of the line AB and the line MN is not minus 1, hence the lines are not perpendicular. So the product of the gradients of MN and AB is not minus 1. So if they were perpendicular, the product of the gradient should be minus 1. So because they are not perpendicular, the product of the gradients is not minus 1. You can see 2 times minus 2 out of 5 equals minus 4 out of 5 is not equal to minus 1. So this is 4. So that is not equal to minus 1. So therefore the James is incorrect. James is incorrect. So I think that's all we have to do for this question.